We already know the derivative of sine and cosine. The derivative of sine is cosine and the derivative of cosine is negative sine. But now that we have the quotient rule and we know that all of the other four trig functions can be defined in terms of sine and cosine, we can actually use those rules to find the derivatives of the other trig functions. So these are the formulas for that. The derivative with respect to x of tangent of x is secant squared of x. The derivative with respect to x of cotangent of x is negative cosecant squared of x. The derivative with respect to x of secant x is secant x tangent x. And the derivative with respect to x of cosecant x is negative cosecant x cotangent x. So you will notice that there are some patterns here. So you've got tangent and you've got cotangent, and their derivatives are secant squared and negative cosecant squared. You've got secant and cosecant, and here you have secant tangent, and here you have negative cosecant of x to cotangent of x. So there's some obvious patterns. You've got the secants and the tangents on this side, the cosecants and the cotangents on this side. These are positive and these are negative. So that tends to be the case. Cosecant and cotangent tend to go together, and secant and tangent tend to go together. You'll see that a lot with several of our formulas that we learned throughout the semester. So I like to prove this one using the quotient rule and using what we know. So the derivative of tangent, we want to prove that this is equal to secant squared of x. So I'm going to start by using the fact that tangent of x is equal to sine of x over cosine of x. So the derivative with respect to x of tangent of x is equal to the derivative with respect to x of sine of x over cosine of x. And if we let f be sine of x and g be cosine of x, then f prime is cosine of x and g prime is negative sine of x. You have to be able to get those positives and negatives straight to be able to do this. So this derivative is going to be gf prime minus fg prime over g squared according to the quotient rule. So that would be cosine of x times f prime, which is cosine of x, minus f, which is sine of x, times g prime, which is negative sine of x, all divided by cosine of x squared. So that's going to be cosine squared of x plus sine squared of x divided by cosine squared of x. And you may remember the trig identity, the Pythagorean identity, that says that cosine squared of x plus sine squared of x is equal to 1. And we could write this as 1 over cosine of x squared, which is secant squared of x, which is what we wanted, so our proof is done. And you can do this very similarly with the cotangent of x. In fact, I would encourage you to try and prove the derivative with respect to x of cotangent of x is negative cosecant squared of x. You're going to use a very similar approach. And of course, we can use these formulas just as they are in any of our rules. So in this case, we've got y equals x squared cotangent of x, and we want to find the derivative of this. So we're going to need to use the product rule here because we have x squared times cotangent of x. So f would be x squared, g would be cotangent of x, so f prime is going to be 2x, and g prime, according to the formula, is going to be negative cosecant squared of x. So y prime is fg prime plus gf prime, that's our product rule. So that would be x squared times negative cosecant squared of x plus cotangent of x times 2x, or if you clean it up a little bit, that's negative x squared cosecant squared of x plus 2x cotangent of x. And that is your answer.